Alright, part 2 of Spring 2018 midterm. So, part 2 starts with question 6, which is file search. So here we want you to connect the ideas that we learned about going through directories in our computer and searching through files. So this is really similar to just, before this class, you probably use something like Finder if you're on Mac to search through your files. And if you're on Windows, just like your normal folders is the equivalent. So, directories are also called folders. So it's just a fancy word for a folder, and files are files. So what we want you to do is write a function called search file, and it takes in a name and directory, and it searches for the file name in some arbitrarily large and arbitrarily shaped directory structure, starting in directory dir. So what this really means, just to summarize it, is that you can't really assume anything about the directory. You just have to use sort of this idea of abstraction, like you don't know what the directory looks like, but given the functions and given the behavior that we described to you, write a function that behaves accordingly. So this will make more sense when we start writing. And the function should return true if the file exists, and false if it doesn't. Alright. And it also is possible for a file and directory to have the same name. Okay, so we have covered the details of the problem. So you might want to look at this diagram to help you out. So this is something you would find in like your Mac computer. You have these directories, and inside there are files, but there are also more directories, right? So you have this sort of nested structure. Okay, and you can also think of this as your doc test. So if you look up page1.html and mysite.com, so it should return true because we do find page1.html inside my site somewhere. It's not directly in my site, but if you keep going down into your directories, you will eventually find it. So it must return true. Alright. So we first want to complete our helper functions. Alright, so these will be the building blocks to eventually create the entire solution. So, you don't want to make these helper functions, but they are given to you. These are the helper functions that we want to start making. Alright, but first let's just go over the ones that are given to us. List content of dir. So it gives you all the files and directories in a directory as a list of names. So this should be something like page1.html, and then so on and so forth. And then there's also this is dir of name. So it returns true if name is a directory, and false if it is a file. Okay, so this is going to be really important. It's going to tell us which is a directory and which is a file, and then we should act accordingly. Alright, so let's just get to creating this helper function called getFiles. It takes in a directory and reports a list of just the files in that directory. Alright, so lucky for us, we have a function that should give us all the files and directories in a directory. Alright, so in this getFiles function, we just want to keep the files. So it gives us both, and we just want to keep files. So we might want to do some list comprehension, because I notice here that we're returning a list. And we're also applying this sort of condition to it. If it's a file, then we want to keep it. If it's not, we want to throw it away. So that signals to me that I want to use a list comprehension. And also the fact that it's just a one-line solution also signals to me that we should use that. Alright, so I'm going to say file for file and list content of dir if so what did I do here? I went through every file. Actually, this is a little confusing. Let's just call it item, since we shouldn't know what it is at first. This is just a small detail, but if you want to be, totally clear of what your code is doing, this is better naming. Okay, so we went through all the items in the list content of dir. So remember, this gives us the files and directories. And then we also use the other helper function called isDir, and we check it against the item. So we say, is this item a directory or is it a file? And remember that if it returns false, it is a file. Okay, so this whole list comprehension is going through the files and directories and keeping what is a file. And that's what we want. Okay, and then we're going to do basically the opposite. So say return you don't actually need parentheses here, so I'm going to omit it. Alright, so that should work. Notice here that I didn't actually put equals true. You could put this is syntactically correct, although it's a bit redundant because this should already return a boolean, and if it's true, well, it just means if true. So this is just correct on its own. You could put this, but as I said, you don't need to, it's redundant. Okay, so now let's just put these all together and actually write the function we're looking for, which is search file. Okay, so we want to sort of think about how we want to deal with the nestedness of the problem. So here we saw that all these directories could be nested within each other. So let's try to break this up into a subproblem. And you want to sort of think about it in a recursive way, because it'd be kind of complicated to look through all of these directories at once. It would be better if we had some kind of solution that just looked in one directory, and if it's not there, then maybe you want to keep looking deeper, and then search for that directory. And if it's not there, keep looking deeper, and if we can't go any deeper and we haven't seen the file, then we know, oh, it's never there, it doesn't exist in that file. So that's the sort of approach that we want to be thinking about, this recursive approach to look at this part of the problem and then make it smaller, and then even smaller, until we know for sure that we have some sort of information about the whereabouts of the file. Either it's in there, or it could not possibly exist. Okay, so I think this will make more sense when I start writing it out. Okay, so I want to check, first of all, is my file in the files of the directory I'm currently in, right? So if I know that right away, then I'm just going to return true, because I already found my answer. I found the file, and I don't need to look anymore. Okay, but if that's not true, then I have to keep looking into the nested directories. So I'm actually just gonna write our staff solution and explain it afterwards. For D, then return I. Okay, so that was a lot of lines. So let me just break it up line by line. So in the very first line, this one, we're just setting a dummy variable equal to false. Okay, and then in this line, we're going to use a for loop to go through all the directories. Sorry, this is an R. Oh man, I just made it worse. Okay, this is an R. And we're going to go through all the directories of the current directory we're looking at and recurse on it. So we're going to use the same function that we're defining right now to look inside of those directories. So here is where the recursion actually plays out. Whatever we're doing in this part of the problem, we're just going to do the same thing to that sub-problem. So remember that recursion always works on a smaller part of your original sort of problem. And so what this means for this case is that we look at a directory that's nested even deeper inside of the directory we were looking at. Right? So it's sort of like, I don't know, you can think of it as those Russian nesting dolls or like those boxes inside of a box. Yeah, so you just keep going deeper and deeper. Alright? And so this line might be confusing for some people. What it's actually saying is that I is going to be set to I or search file of name and name D. And whichever is true first, it gets set to that. If not, it gets set to false. So I'm actually just going to rewrite this because I think it's a little confusing. Alright, so if you looked at the solution, this might be confusing to you, but you can write it this way instead. Oops, sorry about that. You can have result be false, and then you can say if search file of name D result equals true. And then at the very end of our function, we want to return result. Okay, so I think this makes a little more sense to me, that when we go through the directories and we recurse on it, if we ever find that the file is there, then we just return, we just make result true. So it starts out false, and if we never found it, this would work because it never gets set to true, and we just return result, which was always false. Okay, so yeah, to summarize, we made these two helper functions to separate files and directories, and then we also use recursion. And recursion was a really great idea here because of the nested structure of this problem. So you were able to look at sort of just this part of the file system, and if you didn't find the file, then you want to go even deeper. Okay?